Before we get into details about aerospace engineering and various domains within aerospace engineering, after all, this course is meant to be an introduction to aerospace engineering and various domains within aerospace engineering. Let's look at some of the things that every engineer should know and should remember forever. One of the main things that every engineer or a scientist should remember is that science and engineering are both evolutionary, right? They evolve. What does evolutionary mean? They don't happen overnight, right? Sometimes you read these stories and sometimes, yeah, maybe inspirational stories, but nevertheless, sometimes you read these stories which say things like, it was somehow the people woke up in the middle of the night, or maybe, kind of, they were thinking and suddenly it came to their mind, some revolutionary idea in science and engineering came to their mind. That's not how science and engineering works. It's always evolutionary, means there is a whole lot of work which happens, so it accumulates over time. So some people do some work, next set of people will add to that knowledge base and so on, and then you come up with a larger picture or a larger model or a larger scientific understanding or a larger engineering marvel and so on. For example, the common story is Newton, was sleeping under a tree and an apple fell down and Newton came with universal law of gravity. That's not how it worked. There is a whole lot of work which happened, and some of those were, a lot of those works were done by other scientists before Newton, and there was a sum total of scientific knowledge available. With that sum total of knowledge, Newton could assemble all those knowledge together and then come up with a universal law of gravitation. So it's not that he just divined it or he suddenly came up with that idea or something like that. That's not how it worked. Whole lot of work had happened beforehand by various researchers. Same thing can be said about anything, right? Almost anything, right? For example, when somebody came up with, I mean, you know who's that somebody, you should know who that somebody is, came up with quantum theory. It's not, again, it did not happen overnight. It did not happen by one single person. Though we give credit to for the, coming up with the whole theory in a coherent manner for one particular person, there was a whole lot of work which happened beforehand. There were a lot of experiments which happened beforehand, and there were a lot of theoretical foundations which were established, which all went into development of this quantum theory and so on, quantum mechanics and so on. So science is always evolutionary, right? So, and you need to read work, you need to first accumulate, you need to first understand all the existing knowledge and then see how you can assimilate them together to come up with something new. So it is evolutionary. So please do pay attention to what has happened so far. That's what we cover in all these courses, saying what are the things that are already known, that are already available. Only when you understand all these things, then you would be able to go to the next level, right? So it is evolutionary and it is a lot of hard work. So please put in that hard work, right? Nothing useful comes out overnight, right? Like somebody said, right, it's 99% perspiration and 1% inspiration. So inspiration alone is not enough. And science is evolutionary. Don't let anybody else say, convince you otherwise, right? It goes one step at a time. It doesn't come all of a sudden like boom, right? Please do have patience. Please do read up whatever is existing scientific knowledge that is there. Without that, you cannot take the next step, right? You cannot establish some new scientific theory or come up with a new engineering product, right? Engineered product. Of course, associated with that, no jugaad. Design and fabrication are quite different, right? Design basically means you understand the physical principles and kind of develop a mathematical model of those physical principles and use that mathematical model to come up with an intelligent way of coming up with the shape, size, etc. of the particular system that you are designing, right? And then once you come up with the size, shape, material selection, etc., then you go ahead and fabricate, right? Fabricate is a more simpler step. Design, how to come up with various dimensions and so on, or design of dimensions or layout and so on, that is what is more challenging, right? So that is design. So coming up with design is quite challenging. Once you come up with design, fabrication is relatively easier, right? And then I talked about Jugaad, right? So if you do Jugaad, you will never understand design, right? Jugaad is basically somehow I get things, assemble them together, do some fabrication, assemble them together. So Jugaad relies a whole lot on trial and error. If you do only by trial and error, then you will not be able to come up with a intelligent design. And if you don't come up with this intelligent design, then you can't improve it subsequently, right? You cannot come up with better versions subsequently. Whole lot of times again in news, we hear about people who did some jugaad and came up with, say, let's say a motorbike running on biofuels and so on, right? There are some common people who come up with that. We should appreciate, we should encourage them. They are showing their creativity. It's very good, but none of them really become products. The reason they don't become products because whole lot of people do not understand the design, right? So if you understand design, if you understand basic physical principles, only then you can come up with a viable product which achieves efficiencies that are required to make it commercially viable, right? So all those efficiencies you cannot tweak just by doing jugaad, right? So if let us say I want to make it a bit more efficient, then I need to understand why things work the way they work, so that I can go back, rework and see where I can tweak things around and make it more efficient. So to improve efficiencies, to come up with better versions, we need to understand design, right? So please pay attention to the design process. The purpose of this entire program is to enable you to be able to design aerospace related systems, aircraft and spacecraft related systems, right? So there are, each of these courses give you a set of tools which kind of help you in designing systems, right? So please pay attention to all those things, right? All these things matter, right? All the physical principles that they teach you in these courses matter. In addition to the physical principles, they use the physical principles and make a mathematical model out of it. These mathematical models and mathematical tools are the ones which help you in designing. Once it is designed, fabrication is relatively easier, right? Of course, the moment I said, they'll teach you physical principles and, apply those things to develop mathematical models, automatically mathematics, right? Mathematics part of it is very, very important. After all, mathematics is considered as language of engineers. So please learn your language, right? And don't be scared, right? Whole lot of times people think math is difficult, and that is just a psychological, barrier. Math is not difficult. Math is just a language. It's exactly like any other language. You take English as a language or your mother tongue, whatever your mother tongue is, right? You learnt your mother tongue, no? So if you can learn your one language, you can learn other languages. There is no big deal, right? After all, there is no kid on earth unless they have some other deformity or um, some other issues. There is no kid on earth which does not speak a language, right? Every kid speaks a language, right? So if you can speak one language, you can pick up one language, you can pick up another language too. How do you learn this language as kids? We observe adults speaking, right? Kids observe adults speaking, they pick up, right? They pick up. Over time, they pick up. They don't pick it up in 1 week. So then you need to have patience. No kid, suddenly it's not speaking and within a week it starts speaking fluently. That doesn't happen. It happens over time. It happens with a lot of practice. They practice. Sometimes they make mistakes and they practice. And that's how they gradually learn this language over time. Mathematics is similar, right? And then for each word, there is an associated meaning, right? For in the regular language. Same way, even in mathematics, for each symbol, there is a meaning, right? For each operation, there is a meaning. So those are all things that you can only learn over time by practice, right? Kids, I mean, any language, any of us, when we were kids, the way we picked up language is that, right? Over time, we picked it up, not just that, by practice, right? We kept on talking, right? In the beginning, we made mistakes. Later on, we got better and better at it. And that's how all the kids learn language, right? I'm making sense. So there is some amount of, as I said, each word has a meaning and we take some time to associate words and meanings. Same way here, each mathematical operations, mathematical symbols have a meaning and we take some time to, kind of associate them with each other. But nevertheless, we need to do it. I mean, we can learn it and it's no big deal. It's as easy or as difficult as any other language, right? And as I said, all of us know a language. So mathematics can easily be learned too in that way. So don't be too scared about math. And as I said, math is very essential, because without those mathematical models, you cannot do design in an intelligent manner, right? So please learn your language. Mathematics is the language of engineers, again to emphasize. Please learn those things. There are 3 different mathematics courses that you go through during this program. Those mathematics courses give you the foundation, mathematical foundations required to build models, right? So those mathematical foundations help you in subsequent courses, whether it's aerodynamics or flight dynamics or aircraft structures. All those courses use this mathematical foundations that you learn in mathematics courses, and further build upon those foundations to develop mathematical models that enable design. So that's very, very important. Please understand, you need to do design, you need to understand design so that you have a viable product. And to do that design, you need mathematical models. To build those mathematical models, you need to learn math. So please learn math, right? And it's not difficult at all, right? It's just a matter of set of principles. However, I should again emphasize, the only way you learn mathematics is through practice, right? So please practice. Don't just read. You take problems, practice problems. That's the only way. Only by using mathematics you can learn mathematics. Again, it's like language. Only by using language, only by communicating, however bad it is in the beginning, you can learn the language. Same way, only by practicing solving problems you can learn mathematics. So please solve a whole lot of problems in each of these mathematics courses. Otherwise, you will never learn mathematics properly, just like you will never learn language properly if you just keep quiet, right? You need to keep speaking. That's when communication becomes better and better, right? Or for the one is language. Let us say, let me give another analogy. You cannot learn swimming just by reading a book, right? You need to go and practice swimming, correct? You need to go jump into the, you may first learn all the basic theory behind swimming, but then you will have to go and jump into it and try and swim. And in spite of knowing all the details of how to swim, you may still not be able to do. With practice, you will gradually be able to swim. Same way, mathematics, first you learn all the concepts in a classroom, fine, but then you need to use those concepts and then start solving problems. In the beginning, you will have you will not be able to do it very efficiently, but you have to keep at it. You have to keep doing it again and again and again till you master that mathematics, right? That's the only way things work, right? There is this cliche, practice maketh man perfect, man or woman for that matter. So please practice a whole lot of problems. That's the only way you will learn, and that is very much required. Anything in life, that's how it works, right? Like, that's why I gave swimming as an example. So this is regarding mathematics part of it, right? You do all this work, and then you do the mathematical model, etc. And then if you are going to do the design, you are not the guy who will be doing the fabrication, right? You are not going to be the guy who markets that product, right, etc., right? So there are a whole lot of people who do this fabrication, do marketing, etc., etc. So they all need to be able to understand your design and the motivation why you came up with design and the utility of your design, right? How do you communicate that, right? Once you come up with a design, you need to be able to tell them, why did you come up with design? Why is your design good? What are salient features of your design, right? Then for a fabricator, you need to give the detailed drawings, etc. And then you may have to, for a marketing guy, you may have to give a sales pitch and so on, right? All these things involve communication, right? So communication is very, very, very important aspect of an engineer, right? Communication, the first step in that communication is proper documentation, right? So documenting, unless you document everything, you will not be able to pass on information to any of these guys who form part of your group, which will productionize your technology, or whatever you came up with, and sell it, right? As an engineer, you need to pay attention to that. Engineer does make products, right, which are commercially viable. So, and whatever you came up with, you need to be able to communicate to people. To communicate, the first and foremost important step is proper documentation. Please understand, you may think that it's all there in my mind, but please understand, most of the things, you lose, you kind of lose forget the details within 1 week's time, or even reasonable fraction even within 1 day's time. So don't always rely on your memory, please write it down. So documentation is very, very important. Whatever you understood, even when you're studying all these subjects, whatever you studied that day, please try to, make notes of it, right? With pen and paper or with typing on a computer, it doesn't matter. Pen and paper, I feel, works better. You pick your tool. But yeah, every day when you read something, immediately you take down notes of in some form, right? Don't just read and say, yeah, I understand, and let me just leave. Please do take notes, because that way that kind of reinforces your learning, right? And you won't forget. So similarly, when eventually when you go out and do your work, enter a job, and even there, everything that you do, you need to document it somewhere. Have a notebook, have a file on your laptop, whatever it is, and then enter all the details of whatever you did for that day, what are the important things that you did for that day, including failures, right? Failures are also an important part of learning, especially in design. So comprehensive documentation is something that everybody needs to remember. Every engineer needs to do pakka, thorough documentation. And then, of course, every engineer should realize efficiency is what we need to achieve, right? So as part of that, please make sure that you minimize energy spent. That's really what we are after nowadays. No, I mean, you look at all these wars, all of these things are being fought at some level, is all for energy security. Whole lot of these wars also. So energy security is very important. One part of energy security is also trying to minimize energy spending of energy, and hence you need to pay attention to minimization of energy in any one of your design. And of course, we need to worry more about the environmental impacts that our designs, environmental impact that our designs are likely to have. So keep that also in mind. Those were all the general things that engineers should keep in mind. Now I'll also talk a few more things which are all more specific also. Any engineer should remember, ultimately we have to make a commercially viable product. Why is it so? Because finally, everybody has limited resource, right? In the sense that, whether it's a household, right? Whether it's your home, or whether it is country, or whether it is a particular industry, the amount of money available is fixed, right? Within that, we would like to extract maximum out of it. So, you need to make sure that your product is economically feasible, right? It's economically feasible, economically viable, right? So the product should be worth the money people pay for it. So you need to keep in mind the economics of it. That's the reason why we also have a course on economics in the later part of this program. But keep this in mind. Every engineer should keep this in mind, that the product should be economically feasible, right? You may come up with a much better product, but it may be insanely expensive, right? Then it doesn't work. Even if it's slightly inferior product in sense of functionality, but then it's very, very cheap, then people will end up buying it and it will be more useful. Am I making sense? Wherein sometimes we do sacrifice some aspects of our design so that we can keep it cheaper, right? Because finally it has to be economically feasible. So in that sense, we may not always make the most optimized design from perspective of physics of the problem alone. We will also take constraints of keeping the cost low in our mind when we are doing designs, right? I'll talk a little bit more of that pretty soon in this course, especially when I'm talking about material selection and all, where money plays a very important role in the choices that we make. So for every one of this choice which we make in our while we are engineering a particular product, we always need to do cost benefit analysis. This cost benefit analysis is very fundamental to all our engineering decisions. I can't emphasize this more. What is cost benefit analysis? How much is it costing me, as in how much, whether it's in terms of time and money, and what is the benefit that I'm gaining, right? If the cost is much higher than the benefit, then it doesn't work. It always works better if I can get maximum benefit for minimum cost. As I said, budgetary constraint drives design choices. So please pay attention to those. So always, of course, we cannot keep on bringing the costs lower and lower. Finally, we need to worry a little bit about quality as well. So there is always that give and take. So there is some kind of optimization that we need to do, wherein we pay attention to quality, at the same time we pay attention to cost. So there is an optimization that we would be able to do. As we keep reducing the cost, quality also could reduce a bit, and then at some particular point the reduction in quality is so much that it's not advisable, right? At that point you are going to freeze your design. And then another thing, please keep in mind, when we talk about cost, it's money, agreed, but then time is also money. In the sense, please pay attention to how much time do you take to come up with a design and so on, right? If you take longer time, there is more developmental time, then there is more money spent. More money spent because there are a lot of people working to develop that design. So you're paying, and somebody they are getting paid, or you're losing. If you're developing yourself as an entrepreneur, you're losing that much of revenue during that period of time. So the larger the developmental time, effectively more money you're losing, right? There is also opportunity cost. If you now bring a product into the market 6 months in advance, you will earn so much more revenue for extra 6 months. So developmental time you have to sometimes minimize, right? So again, for that reason, you sometimes need to keep analysis simple. That's where in all the courses that you have in subsequent part of this program, there are a whole lot of assumptions that we make to keep our analysis simple. But of course, it cannot be so simplified that it comes up with an inefficient design, right? So it has to be simple, but nevertheless, it needs to have all the features required to come up with an efficient design, right? That is where in aero it is even more cutting edge than any other domains, let's say civil or mechanical, because at the end of the day, if we don't go for efficiency and optimize, I can't be airborne because I need to go against gravity, right? I need to take off, lift off by defying gravity. So given that, our analysis has to be thorough, but within that thorough analysis, we make as many assumptions as possible to keep the analysis simple. All of them will be discussed in these courses. So these are all things that you need to worry about, right? And I already talked about opportunity cost. So time is money also fits into that, in the sense that the more you delay, you're losing all this opportunity to sell this product. So keep in mind, that you need to minimize time, you need to minimize money, right, or cost of the product. Another important part is communication. Already kind of dwelt on it when I said, documentation. That is a must. I mean, that's very, very important. Please make sure you document everything. Otherwise, it will go out of your memory, right? So the documentation is in one part. In some sense, that's more of, making sure you have the database. But then you have to communicate the database. The typical communication we do either orally or in a written form, right? So written form in terms of reports, in terms of a thesis or whatever it is, and orally we do make presentations, etc. Right? This communication is extremely important for a engineer, right? It's not sufficient to do technical work. All this technical excellence is of no use if you cannot convey it, communicate to the other people, right? As I said, you're not going to be one man army developing the product, then going and fabricating, and then going and marketing, and etc., etc., right? Even if you're doing all these things, finally you need to be able to communicate the good things about your product for people to buy, right? So the people won't buy unless they're convinced. So you need to be able to communicate in a convincing manner, right? So please remember, communication is extremely important. Communication of all forms, right? And that's the reason why we have a bunch of English courses, because whether you like it or not, in today's world, if you want to reach the widest possible audience across the world, then English is the mode of communication. So that's the reason we have those courses on English right in the foundation level. Please pay attention to those, right? Communication bridges the gaps between engineers, fabricators, managers, management, the kind of marketing people, and the end users, right? There is communication between all these people, right? A miscommunication can also lead to design flaws and project failures, and hence actually eventually becomes costly. Of course, one thing I forgot, even when you are designing, it's usually not one person designing all aspects. There are different people designing different aspects. If they don't communicate with each other properly, you are going to lead to design failures, and that will cost money. We will see a little bit later on in this course, wherein there is aerodynamics part typically is done by a different person for an aircraft. Structures part is done by a different person, analysis wise. When you try to put them all together, they may want conflicting things, right? And without going into details, I'll go into details when I discuss them later. For example, an aerodynamics guy would want the wing to be as thin as possible, airfoil, what we call as airfoil section, to be as thin as possible, whereas a structures guy wants it to be as thick as possible. So unless they communicate with each other and try to tell, unless the aerodynamics guy tells what is the reason for his decision to structures guy, and structures guy again tells what is his reason for the decision, they can never come up with a solution which satisfies to an extent both of them, right? So some sort of a compromise has to be reached. For that compromise to be reached, they should be able to communicate clearly to each other, right? Aerodynamics guy, he cannot show all the may not be able to show all the mathematical details, but nevertheless he needs to be able to convince the structures guy why it should be thinner, and structure guy should be able to convince the aerodynamics guy why it should be thicker. All this form part of communication. So even within the design team, you need to communicate with each other. Then once you come up with design, you need to communicate with management, marketing guys, end users, and so on. So communication, very, very important. And one part of that communication is, first, be precise, right? Be precise about what you say, right? Don't make it too vague, right? Be very, very specific, right? Don't use short sentences, etc. Make sure it's completely clear. Don't assume anything when you write, right? Assume that assume that the other person doesn't know anything, and make it very, very clear. At the same time, be concise, right? And be a bit brief, right? Don't make it too verbose. There are so many times you see articles written in a newspaper. I sometimes read the entire article, which may be 2 pages long, and I say, hey man, I can summarize it in 3 sentences. That's all it is. The same thing he's saying again and again in different ways. Don't do that, right? Don't keep saying same thing again and again in different ways. Say it once, but that one time that you say it, make it very clear, make it quite elaborate. Don't repeat, right? So be brief, at the same time be comprehensive, right? Make sure all the things that you want to communicate is out there, right? Don't keep using pronouns which are difficult to link to the earlier sentences and so on. So be very clear, right? And give all the relevant and necessary information, but with fewer words. Don't be too verbose, right? Don't be too verbose. Don't repeat yourself. Though in teaching I keep repeating myself, that serves a different purpose, that is to reinforce. But when you're writing, or when you are in general giving a presentation in a conference, avoid repetitions, right? And then also still cover all the topics that you want to cover. Use complete sentences when you're writing reports, right? Don't put half sentences. Don't use too many abbreviations. All these things are inefficient forms of, kind of communication. So when we talk about clarity in communication, also avoid using too many abbreviations, um, because abbreviations can mean different things to different people, right? So one of the things I was discussing with my students, one of my students, she was talking about perfectly matched layer and so on, and instead of that, she was abbreviating as PML. And in a recent movie, the same PML was Pakistan Muslim League, right? So the same abbreviation can mean different things to different people. So avoid using abbreviations as much as possible. Now that I've emphasized and repeated so many times about the importance of communication, let me talk a little bit about different forms of communication, right? One is obvious written communication. So that written communication is something that we already discussed. It's there in the form of technical reports, documentations, emails. In all these cases, it is better to have complete sentences, full sentences, and then be very clear. Don't assume they know anything and then you just put everything down, right? At the same time, don't repeat, right? As I said, though I'm repeating myself here, that's for educational purpose, but when you put in a report, don't repeat too much. Then there is verbal communication. Verbal communication could be in the form of presentations, meetings, teaching like this, and in the form of team discussions, right? That's another form. Then visual communication in the form of maybe diagrams, detailed diagrams, technical drawings, charts, figures, and so on. So these are all various forms of communication. You need to ensure there are differences in each of them. You need to ensure that they are all taken care of. One part of it is language, which you will learn in English courses. But this kind of communication is also something that you need to pick up over time. One important aspect of communication is actually listening, right? So communication is not just about talking. It's not about communicating your part, right? Whole lot of times, especially when we are talking about verbal communication, that does not happen like this as a lecture. A lot of times it happens as a discussion, right? And when the discussion is happening, active listening, the listening part of it is also equally important. So please listen to the questions properly, right? Listen to the questions and comments properly before you start speaking, right? So whole lot of times people have tendency to assume things, right? Let us say I start asking a question, halfway into the question, you already assume the rest of the question. You already assume you know what the other person is asking and start answering. That is the worst part. Or even otherwise, you are at the halfway through the question itself, you will start thinking about answer to the question even without listening to the question properly, right? Please learn how to listen as well. That's one important part of communication. Wait for the other person to finish his point or question, right? Don't assume. Don't start thinking before he or she asks that question, right? Don't assume. Don't say halfway through, I know what is going to be the rest of the question. Don't get into that habit, right? So that's an important part, active listening. Then each of those things, written communication is writing reports. Hopefully you'll learn as you take these English courses. Presentations is and visual communication is what you need to pay a little bit more attention to, because you may not learn it in any particular course. So I'll give a very brief intro to that. Especially when we are making slides, right? So that's very important. So let me give an introduction to how to make these slides and make presentations. Here I have made a very brief template for presentation, general presentation. So I'll present the same. Of course, in any presentation, typically the very first slide is title slide. So where you put title and who is presenting, why are you presenting, right? What is the occasion and so on. The context basically. In addition to that, also try to have one, I guess motif is the right word, basically have fix a nice background, right, for your slides, right? Here, of course, I have put the IIT symbol and the department and so on in my presentation. So then now coming to the particulars of how you should make these presentations, right? Small things that you need to pay attention to is make sure your font size is the most important thing, right? Make sure your font size, it is not less than 18 if you're using Arial or equivalent, and not less than 20 if it's Times New Roman or Calibri or Cambria or some equivalent fonts, right? Otherwise it is not very clearly visible, irrespective of which device you use, right? So make sure that the font size is minimum 18 to 20, right? And all the, even the figures, let's say you are embedding some figures in your presentation, even those figures should have fonts which are equal to 18 or 20 font size, right, in the regular text. And then make sure that there is some paragraph spacing, maybe about 12-point paragraph spacing. And then when you're having all these fonts, and let's say if your background is darker, choose a lighter kind of fonts for lighter color for fonts. And if your background is lighter, choose darker fonts, right? For example, here you can see that with a blue background, darker blue background, you may want white font. Then similarly, if you have lighter background like the rest of the slide, you may want to use a darker font like the black fonts and brown fonts that I've used, right? So that's something then you should pay attention to. Make sure minimum font size is 18 to 20. Make sure that there is contrast between the background and the font color, right? So typically, you need to have most of the slides you should not overdo on the colors, right? Don't put too many colors out there, they are very distracting. You need to use colors judiciously. For the most part, the presentation could be in one or two colors. Only things that you want to highlight, you may want to put them in different colors. So you can use colors a bit more judiciously, but don't overdo, don't make it too colorful. That doesn't work. Again, similarly, you do bold and italics only when you want to draw attention to a specific word or phrase. Don't overdo, don't make everything bold or everything italics and so on. Don't overdo those things, right? So that's something that you need to keep in mind. Right. Other thing is don't capitalize entire text, right? Capitalization basically means you are shouting loudly, right? Don't keep shouting in your presentation, right? So capitalization is only when you want to really emphasize something, right? When you want to say all of it is wrong, right? Then you say, you capitalize ALL alone. So you want to emphasize something, then you want to make it in all caps. Otherwise, don't make it all caps, capital letters, right? And don't use very complicated fonts like the one I'm showing here. No, all this nice artistic looking fonts, but they're not easy to read. So make sure the fonts are easy to read, right? Animations are very useful, but then don't overdo on animations, right? Because if you overdo animations, it's distracting. If something is always moving in background, people are only paying attention to those moving things and not paying attention to what you're saying. And the purpose of a presentation is not to make them read your slide, but to effectively listen to you. They should be listening to you for the most part. The slides are only for some cues, right? If there are some details that they need, they can look at the slides. For the most part, they should be listening to you, right? Whereas if you have something moving all the time in the background, people will not listen to you, right? And so don't write some text and keep reading from that. You need the text. What you write in a slide is not complete sentence. What you write in a slide is only going to be some cues to you for elaborating on some things, right? Don't write the entire sentence and keep reading that sentence, right? That doesn't work, right? So you need to have only some short phrases and other things that give you an idea as to what you want to speak. For the most part, they should be listening to you, not looking at slide. And then of course sometimes you're doing visual communication wherein you're putting a figure or a flow chart. At that point of time, of course you need to pay attention to what is there on slide. And so those things are something that you need to keep in mind, right? Make sure that it's not too dynamic while using animation, right? So again, one other thing, typically avoid bright backgrounds, though, when you're making the slides. In general, in slides, don't make them, don't have to make them paragraphs after paragraphs. Make them in the form of bulleted points, and don't have more than 5 or 6 bulleted points in any particular slide. And any bullet point should not be more than 2 to 3 lines, right? Then it doesn't look good. So about 5 to 6 bullet points, each bullet point between 2 to 3 lines, even 1 line. That's fine. So especially whole lot of times, whether it's in report or in presentations, we embed figures, right? Figures that we make using different software. And while making these figures, be careful, right? Make sure all fonts are similar in size, right? For example, this figure that I am showing here, right? If you look at this figure, in this particular figure, your title of the figure is in very large font, but your y-axis is in small font, and that is not very good, right? Make sure that all fonts in each of these figures are all of similar kind. If you are sometimes reusing figure from somewhere else, you can always add a additional text box on top of it and make it better looking like this, right? If you do this kind of a modification where you are adding your own fonts and the size, now this here all the fonts are of similar size, and when you are embedding it in the slide, you look at the slide. My slide, the font size of the regular text in the slide is 18 font size, right? And even the figure, the font size looks similar. Don't make figure font size look too small or too large. It's very bad look. It doesn't look good, right? So that's something that you need to keep in mind. Even when you embed a figure font size should be similar to text in remaining portion of the presentation or the report, and all the various parts of your figure should have similar fonts. So this is a kind of a brief input I wanted to give on presentations, right? In presentations, don't you don't have to use complete sentences. You can just put bullet points. Make sure font size is 18 to 20. So make sure that all fonts are similar. Don't you use colors judiciously. Use colors, different colors to highlight certain things. Colors, bold, italics, etc. But don't overdo these things. It will not look good, right? So these are all things that you should keep in mind. And of course, contrast. The background is light. Your font has to be dark, and then if its background is dark, fonts have to be lighter. These are all the simple things that you need to keep in mind when you are making slides.